My name is John Murphy, and I'm a principal systems engineer for Ruckus Networks. And I'm sure everyone here has heard a lot about AI, artificial intelligence, this week. And I want to spend just like 1 minute talking about what I'm going to call natural intelligence, which is really just people working with people. And you probably noticed we have this banner back here about the Ruckus technical family. And what the Ruckus technical family is just a formalization of like the Ruckus SE culture. And the Ruckus SE culture is just to be out there in the trenches, working with our customers and listening to our customers. And listening is the big thing, right? And one thing that my customers have been telling me for a while now is that we have some gaps in our portfolio. And they ask me questions like, where's your border router that has internet scale for BGP that connects my network to the internet? What's your SD-WAN platform? And you've been doing really interesting things with dynamic pre-shared key, but how do I integrate that with my property management system? So I'm very pleased to be able to talk about today a new product, which is the RUCKUS WAN Gateway. So every network, for the most part, connects to the internet, and every network needs some kind of border gateway to make that connection to the internet. And so the RUCKUS WAN Gateway is now the product that we have so that I can start answering yes to those questions instead of no to those questions. And so we're going to talk about what this is. So RUCKUS WAN Gateway is software that you can deploy either on a VM or you can deploy it on bare metal. And I want to talk a little bit about the history of the lineage of where this product comes from. So what we have done is we partner very closely with RGNets, which is a company founded in 2006, and they produced one product, which is called the RxG, and it's a WAN gateway. They've partnered with Ruckus since day one. So there's some close relationships there that have been ongoing. And you can see some of the stats there of some of the kind of networks that this software is running in. Three of the 6 largest telcos, 2 of the 4 busiest airports, 3 of the 15 largest hotel management companies. And they've got 7,000 plus installs. Okay, so you can deploy this software, and this is now a Ruckus product. We have a Ruckus version. And you can deploy it as a virtual machine, or you can deploy it on bare metal. If you want to run it on bare metal, there are some advantages that I'll get to in a few minutes. And if you have a preferred bare metal server platform, we can work with that, but we partner with Dell to make it very easy. So if you want to run on Dell hardware, we can provide you with sizing guides, specific server models, depending on the size of the network you're trying to install into. So then, got some updates installing here, getting in the way of my presentation. So then, as I mentioned, it's a Ruckus product. So you can see it's Ruckus branded, RWG, and there are really just a ton of features in this product. I don't have the time to get into the details, and we're not going to give you a detailed demo today, though I hope we'll have the ability to do that in the future, because there's a lot of really interesting things that can happen when you put all this functionality into one product and you have a centralized place that you kind of stitch some of these features together. But the number one thing that I want to convey with this slide is it's a Ruckus product, it's Ruckus branded, and we stand behind this product. So if you buy RWG, it's just going to come with Ruckus supports that's built in. And we also have Ruckus Professional Services if you want our help deploying it. That's all ready to go. This product, by the way, is available today. It's orderable. So this is live. It's on our website.
So you're excuse me. So you're saying this is RGNets with additional Ruckus features then tweaked or that Ruckus added to it? And
so as it stands, it is basically the same functionality.
Okay.
But what we've done is we have been partnering very closely with RGNets at the engineering level.
Okay.
And so if you go back and look at some of the release notes and things, you can kind of see the results of that. There's been a lot of fine-tuning of the Ruckus integration, and there's been a very close back and forth at the engineering level, and we're working very closely there. So we might see some of that in the future, but for now, it's the same functionality, more or less.
Okay. And I guess it supports multiple vendors, I'm probably assuming then?
Yeah, we have not removed any of that functionality.
Okay.
So yes. So if you want to go into a network and you've got other vendors' hardware, RUCKUS WAN Gateway can actually have that functionality of integrating and even doing some of the automation across those platforms.
Okay.
And that gives you some unique abilities where as you're refreshing a property and you have, over time, I have to work with multiple vendors, but I want to do interesting things with authentication and pre-shared keys. I can now put this product in, and it can put in those ties via APIs, SNMP, SSH, et cetera. to be able to give you more of a cohesive management across those different products.
Okay.
So if you're not familiar, what does it do, right? What does the RUCKUS WAN Gateway do? So first of all, there's a lot of these complementary services that you need for any network, right? So DHCP, DNS, you need to NAT things out to the internet. We need some kind of routing, right? BGP, could be static routing. So we support BGP, static routing, IPv4, v6, dual stack. We have SD-WAN functionality, so we can create VPN tunnels between RDBGs, and we can control via policy traffic that gets steered into those tunnels. So we've got that SD-WAN functionality now. That's a big gap that we've had that we've filled. And then, of course, you have things like traffic shaping, so where you have public networks or hospitality, MDU, large public venues, there can be a lot of contention for the available WAN links. So we've given you some very fine-grained controls over how you can police and shape that traffic. And of course, we've got a radius server built in. And with that radius server, we've also connected to our RUCKUS DPSK technology. And we've done some creative things there that I'll show you on the next slide. In MDU and hospitality networks, where we really see probably the best fit in terms of just like the extensive range of features that we can bring here, there's this concept of a virtual resident gateway. So if you think about going into an apartment complex where people want to have what feels like their own network, and they want to feel like they manage their own network. So they're going to want their own, like you saw some of the portals that Christopher showed. So similar to that, I want something that I can manage my devices, and I can see what's happening with my devices. I can change my DPSK. I can basically, it feels like my network, right? And I can also do things like maybe upgrade to a paid plan, which, by the way, we can handle the payment for you. And that paid plan could have things like, I want a static public IP from that pool that you have. So now I have my own public IP, and I can do my own port forwards in my gateway, or I can turn on UPnP, and I can control all that functionality. It feels like my network, right? All my devices can talk to each other, but I can't see my neighbors, etc. So specific to hospitality, PMS integration is a big thing, right? MDU as well, and one of the really cool things that we can do with RUCKUS DPSK is by tying in with the RUCKUS WAN Gateway, we can now do very interesting things like, instead of using a captive portal, which I'm sure we all love using captive portals, but what if there were a better way? And instead of going to a captive portal and typing in my last name and room number, what if I just connect directly to a secure pre-shared key SSID, and my pre-shared key is my last name and my room number? And oh, by the way, I don't care how you capitalize it, or if you put the room number first or the last name first, doesn't matter, right? Because we have something called DPSK mangling, which sounds bad, but it's actually good. It's really cool. You can see in this flow diagram here, basically what happens is, I just associate to the SSID, and my password is my room number and my last name, right? We go talk to the PMS database, and we can see what's happening there. We can match it up, and then we can assign you to your own unique VLAN, your own unique subnet, apply whatever policy, traffic shaping, SD-WAN steering, whatever it might be. And it all ties into that PMS database. And if I have, say, a paid upgrade plan, like I mentioned, we can post that charge right back to the folio.
Question. So can I not do at least some of this through that, what we earlier talked about, persona management, for example?
Yeah, that's a good point. So part of the reason I shared some of the history of this, coming from RGNet, so there's some parallel development that's been happening there, and there's some things we're doing in RUCKUS One, right?
Okay.
Our intention as RUCKUS is that RUCKUS One is the centralized point of management for everything that we do, right? So those discussions are taking place.
Okay. So we expect to then kind of eventually see this all in the cloud. Did you say RUCKUS One? Is that what you said?
Sorry, RUCKUS Cloud.
RUCKUS Cloud. Okay.
Yeah. And then the other thing that I think is really interesting about RWG is this concept that we call auto increment. And so what you're seeing here is, think about deploying an MDU network where I want to give out like a personal VLAN per user. When you do that at scale, it gets to be a lot of stuff that you have to configure, right? So what you're seeing here is just two dialogues in the interface. The dialogue on the left, you're creating a VLAN, but actually you're creating a group of VLANs that right now has one VLAN in it. So we start with VLAN ID 200. And then there's some auto increment settings. And what we're basically saying here is just, I want each VLAN to match to a subnet, 1-to-1 ratio. And then on the right, what you're seeing is I'm defining a subnet. In this case, it's a /30. And so what happens is I set my auto increment to 64. And now what I have is 64 VLANs. Each of those VLANs is tied to its own layer 3 gateway. It happens to be a /30 in this configuration. So I have my host and the gateway and nothing else. Right, so very secure. And I've got 64 DHCP pools, and that's all managed as a group of DHCP pools. It's not like I have to go in and configure 64 different things. So I've created a group, and in the back end, I've got 64 of all that stuff. And that was like 2 clicks. So you can see where that starts to really amplify your ability to deploy things with less labor. And then you can also tie in what you mentioned about integrating with different kinds of hardware. And now I can push those VLANs out across all my switches, right? So it's the RWG is going to be able to synchronize the configuration. And as I create VLANs here, I'm going to see those VLANs in the switches. That just really makes everything easy. And also, by the way, a lot less chance for error, right? Because when you do
the
that
other hardware technically would be just layer 2. I mean, all the layer 3 and everything is happening here.
it's all happening here.
Right. Okay.
Yeah, basically at that point, all you're having to do is like plumb your VLANs through the network. And then the other main topic I want to touch on is the idea of security. And of course, in addition to AI, we have this other big buzzword called zero trust. And zero trust has lots of different definitions, but in general, you have different elements you need to bring to be able to have a zero trust kind of architecture. And so one of those is you have to be able to authenticate your users. With RWG, we can reach out to various types of backend authentication databases. So we can use SAML, we can use OAuth, LDAP, mention the PMS integration, and then we also have self-sign-up ability. So I can just hit a captive portal, put in all my details, get a free account, or maybe I've got paid accounts, so I can get a paid account, put my credit card information, whatever. Okay, so I've identified my users. Now, I also need to know about those devices, right? Because just because I trust the user doesn't mean I trust the device. So the other thing we can do is do device profiling. So we can do active scanning, so where we reach out and do like port scanning, and then compare what we find in that information against vulnerability databases and assign a CVSS score to that device. We can also talk to a posturing app or work with a customer to build the posturing into their own app, like a hotel loyalty app or something like that. So we have different methods there. So we can posture the device, and we can validate that we know who the user using the device is. And then we can control what's happening with policy. The policy is kind of where all the magic comes together. The fact that you can centrally tie into knowing what the VLAN is and having all the DHCP information, and then the device profiling information, the account information, and then we can stitch together whatever we want to happen to that traffic with policy. So I talked about the microsegmentation, standards-based microsegmentation. You just pick your subnets, your VLANs. If I want to give out a /24 to all my tenants, that I could do that just as easily as you saw with the /30 example. And then we have firewall and content filtering. So if I want to do things like, make it such that when I hand these subnets out, they can only talk to their own subnets and maybe the internet, or however kind of fine-grained policy I want that to be, down to the application level. I can also do things where I dynamically change the policy that's associated to a device. So we have things called event triggers. I can go in and look at various things like what's happening with different logs, what's happening with IPS and IDS rules. And based on what I see there, I can change the policy that's applied to that device. Or I might want to look at something like connection information. So if I'm seeing a large number of new connections happening from that device, maybe I want to trigger something to happen. Maybe I want to reclassify that device, assign a different rate limit. Maybe I want to go back and reposture that device, do a vulnerability scan. Maybe something's happening with that device. Why is it all of a sudden making all these connections? So I can look at all these different dynamic things that are happening in the network and change the policy on the fly. And then we have the ability to run virtual network functions, or VMs, basically. So there's a hypervisor built in, and then you can, with the policy, steer traffic through those VNFs, if that's the use case you have. And then, of course, SD-WAN, we can assign on that policy level which uplink I want to prefer for that specific type of traffic from that device. And then, of course, we'll fail over if that uplink goes down.
What about the licensing? Is it going to be exactly the same as like kind of what for example, I've seen with RGNets, or Ruckus is going to have a different licensing, maybe
Yeah.
more simplified? Possibly?
It's a little bit more simplified.
Okay.
So it's basically just like a subscription per device. So it's a per device kind of licensing. And there's some add-on licenses, depending on what your needs
How
are.
many add-ons though? Because
So basically, it is pretty simple. In most cases, you have just the one SKU, right? And that it's based off your device count, and that also gets you a certain amount of throughput and different back-end kind of counters. In most cases, that's going to work out for you. But if you have certain kind of edge use cases, like I have very few users, but I want to support high bandwidth, then there's a bandwidth upgrade. Okay. Or if I, for some reason, have like a tremendous amount of policies, I can do a policy upgrade. Okay. Typically, it's just going to be the per device. So I mentioned there's a hypervisor built in. So that gives you the ability to do interesting things at the edge. So if I'm going to put this device out at the edge, in addition to all of the stuff that it can do natively, I can run VMs inside of this device, and then I can stitch traffic through those VMs, where and when I need to. So things like Smart Zone and data plane. So if I want to have a tunnel endpoint that I need to put somewhere, putting it on the property, if I can run it inside the same box that's hosting my gateway, well, that saves me some cost. I can put our IoT controller. So all of the great stuff you heard from Andy, all those IoT devices need to talk back to that RUCKUS IoT controller, and we can actually run that inside the RWG. And then the other thing we can do is, in addition to third-party VNFs, the really interesting thing to me is we're now looking at running an evolved packet core inside the RWG. And that brings me to my last slide here, which is kind of the latest thing that we've done with this idea of converged networking and EPC. So we have this idea of a converged policy. And we're going to take it back to Jim, who kicked us off. So you can see here at the bottom, you've got Jim. And Jim has an account. We've decided to assign Jim VLAN 1235. The basic idea here of a converged policy is, I want Jim to be on VLAN 1235. There could be other stuff there, like rate limits and firewall rules, whatever. But let's make it simple. Jim's on VLAN 1235. So when he connects his laptop, he's going to get VLAN 1235. But now also, if he connects his phone to a CBRS AP, I can put that phone on the same VLAN. So basically, what I'm able to do is, behind the scenes, I can connect together those devices that are on completely different media, and then apply the same policy to both. And if we have IoT devices, where that device needs to be on a VLAN, we could map that, or maybe it's just something like a door lock in this case, and I need to make sure that Jim's the only guy that can control that door lock. So I can associate a Zigbee device to his account, and I can associate a CBRS device and a Wi-Fi device, or it could be a wired device, and put them all on the same VLAN. So we tie it all together. So we've actually POC'd this, and showed this ability where we can tie a SIM card together to an account, as well as Wi-Fi, typically with a dynamic pre-shared key. I put my DPSK in, I get the policy. I put that SIM card in my device, and I get that policy. And we're looking at ways of making this even more streamlined, like doing things like being able to issue eSIMs and do a single sign-up on Wi-Fi, which provisions you for both Wi-Fi and a private CBRS network. Okay, so that's really all I had, and that brings us to the end of our planned presentation here. So yeah,
I got a question. You said that you can include the evolved packet core in this. What did you mean by that?
So we've virtualized an EPC running on the bare metal platform, which includes a hypervisor. So
you've
on the
got
border gateway,
serving nodes and mobility management gateways on there, virtualized. Is that what you're saying?
Yes.
Those functional nodes are running on there. And will the 5G nodes network nodes also be virtualized on there in the future?
So we're exploring that. So what we've started with the existing LTE CBRS nodes we have, and then we are definitely looking into 5G.
Okay, but it's the core network, not the radio nodes that you're virtualizing, right?
That's correct.
Right. Okay, thank you.